This TCA stands for what? Tricarboxylic acid. So tricarboxylic acid cycle, or you name it after the person that discovered the pathway, Hans Krebs. Hans Krebs was the person that discovered this pathway. So it is also named after him as Krebs cycle. Or you call it citric acid cycle. As we go into the pathway now, you'll see that the first stable product of this pathway is citric acid. And that is why it's also called citric acid cycle. Now it is called tricarboxylic acid cycle because citric acid is a tricarboxylic acid. Like if you draw the structure of citric acid, you notice that it has 3 carboxylic acid functional groups. That is why it's called tricarboxylic acid cycle. Do we get that? Now let's go into the pathway. But before then, remember that pyruvate was what we produce in glycolytic pathway, right? That was the end product of the glycolytic pathway, pyruvate. Now if oxygen is present, that pyruvate, how many moles of energy did it generate from glycolytic pathway? 2, right? Just 2 molecules of ATP. That 2 molecules of ATP cannot carry you. You cannot do much with that. It's very small. So we need more energy. We need to get more energy from that 1 molecule of glucose. Now the purpose of the TCA cycle is to generate more energy. So generate more energy. Do we get that? That's the basic purpose of the TCA cycle, to generate more energy. Now I'm going to start with pyruvate. Don't write yet. Pyruvate was gotten from the glycolytic pathway, right? Now if oxygen is present, pyruvate will undergo what we call oxidative decarboxylation. Decarboxylation means what? Removal of what? Carboxylic acid group, right? Good. Now if this is the structure of pyruvate. This pyruvic acid, pyruvate. Now when we say oxidative decarboxylation, removal of what? Carboxylic acid group, right? This is removed. If this is removed, we will be left with what? This, right? And this acetyl group. Is it not? Acetyl group. This is acetyl group. If you attach coenzyme A to acetyl group, what do you have? Acetyl-CoA. This is acetyl-CoA. Now, first, pyruvate undergoes oxidative decarboxylation to form acetyl-CoA. Now, I must say that this reaction is not part of the glycolytic pathway and is not also part of the TCA cycle. It is called the linked reaction, a link between glycolysis and TCA cycle. So this is the reaction that links glycolytic pathway with the TCA cycle. Do you get that? Yeah. Now, pyruvate is converted to acetyl-CoA. But remember I said, as I drew the structure of pyruvate, decarboxylation will remove what? CO2 was removed, right? But what is coming in? Let me see who's thinking first. CoA, right? CoA was coming in. So you write your CoH. Ash because it's a sulfide bond. So CoH comes in, donate the coenzyme A group, and we get our acetyl-CoA. Greatest metabolite, acetyl-CoA. Now the acetyl-CoA is the same since. This is the acetyl-CoA. So if you are asked, how do you get the acetyl-CoA that you are answering your own name? You now be. So now that you are gotten from what? Pyruvate, is it not? Though there are many sources of acetyl-CoA, this is just one. But just know that pyruvate undergoes oxidative decarboxylation to form what? Acetyl-CoA. Now, this acetyl-CoA has been formed now. Do you know why TCA cycle cannot take place without oxygen? Who can point it out for me? Why can't the TCA cycle take place without oxygen? Okay. Yes. Look at it, look at it, look at it. What is this name? Oxidative decarboxylation. Oxidation reaction is taking place here. Oxygen is needed for this reaction to take place. Because what is actually happening is oxidation reaction. So if oxygen is not present, you cannot get acetyl-CoA. Without acetyl-CoA, TCA cycle cannot take place. Do you get that? Without acetyl-CoA, TCA cycle cannot take place. And so, now that we've gotten our acetyl-CoA, the next thing, TCA cycle can take place. Now these are the reactions of the TCA cycle. I'll give you time to write, so just listen up first. But if you forget everything we've said today, don't forget that in the glycolytic pathway from glucose to... You don't have to talk. You are alive. Your parents is seeing you now. You are alive. From glucose to what? From glucosylceosate to what? Fructosylceosate to what? Fructose dissociate to... Raise up your head now. From glucose to glucosylceosate, glucosylceosate to fructosylceosate, fructosylceosate to what? Fructose 1,6-bisphosphate. There will be a cleavage to what and what? And glyceride 3-phosphate, right? Dihydroxyacetone phosphate cannot continue, so it's converted to another molecule of what? Glyceride 3-phosphate. Now glyceride 3-phosphate is converted to 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate to what? 3-phosphoglycerate. 3-phosphoglycerate to 2-phosphoglycerate to pyruvate to... That is the part everybody knows, pyruvate. Now we've gotten the pyruvate. Pyruvate undergoes oxidative decarboxylation to form what? Remember, the glycolytic pathway takes place in what part of the cell? Cytosol. Now, if you look at this, let's take this as the cell. This space you are seeing here is the cytoplasm, right? And the fluid in this space is called the cytosol, is it not? This is your nucleus, is it not? And you have your mitochondria like this. Remember, mitochondria is the what? Powerhouse of the cell, right? Why is it called the powerhouse of the cell? That is where what? Energy is produced. Cellular respiration takes place. That's where energy is produced. And how is the energy produced in your mitochondria? TCA cycle. Part of it. So now, remember TCA glycolytic pathway took place in the cytosol, right? And the end product of the glycolytic pathway was what? Meaning that pyruvate is in the cytosol. But TCA cycle needs to take place in the mitochondria. Because the enzymes of the TCA cycle are found in the mitochondria, not the cytoplasm. So pyruvate can be transported, is transported to the mitochondria, where it is converted to acetyl-CoA. So note that, I'll give you the note. TCA cycle takes place where? In the what? Mitochondria. Now, acetyl-CoA has been formed. The first step now in the TCA cycle, this acetyl-CoA, please note this because if you understand it, you already know glyoxylate pathway. Yes. Acetyl-CoA, first of all, we condense with oxaloacetate to form what? Citrate. Don't write it. Acetyl-CoA has how many carbon? 2 carbon, right? 2 carbon. Oxaloacetate has 4 carbon. 2 plus 4 give us what? 6. This is the first product we are forming in the glycolytic pathway. Citrate. That is why this citrate is citric acid. That's why we call it citric acid cycle. And it's a tricarboxylic acid. That's why we call it tricarboxylic acid. Do you get that? Now, citrate has been formed. I'll give you the enzyme later and other stuff. So let's get the substrate first. From citrate, there is a very transient intermediate called cis-aconitase. Cis-aconitase. Some books omit this because it's very transient, it's very unstable. Now, from cis-aconitase to what? Isocitrate. From isocitrate to alpha ketoglutarate. From alpha ketoglutarate to succinyl CoA. From succinyl CoA to what? Succinate. Succinate to what? Fumarate. Fumarate to what? Malate. And malate back to oxaloacetate. This is the TCA cycle. This is the TCA cycle. We just have to put the enzymes and the reducing equivalents, and that's all. MHR lamp. Alright, so note that first pyruvate is converted to acetyl-CoA. Acetyl-CoA condenses with what? Oxaloacetate to form what? Citrate. Now citrate is converted to what? Cis-aconitate to what? Isocitrate now to what? Alpha ketoglutarate. Alpha ketoglutarate to what? Succinyl CoA. Succinyl CoA to what? Succinate to what? Fumarate to what? Malate back to what? That oxaloacetate combines with another acetyl-CoA to form what? The citrate to what? You now see why it is called cycle, right? It's continuous. Once this is formed, it still combines with this, and the pathway continues like that. Alright, now basically this is, we are going to take it again, but before then let's look at the enzymes. Now, acetyl-CoA condenses with oxaloacetate to form citrate, and the name of this enzyme is called what? Citrate what? Synthase. Enzyme that is synthesizing citrate. So we call it citrate synthase. Citrate synthase. Now the enzyme catalyzing from citrate to cis-aconitate is called what? Cis what? Aconitase. Notice that the name of the enzyme ends with ase. Cis-aconitase. Now the same enzyme is catalyzing this reaction. So this cis-aconitase is catalyzing this and this. So here we still have cis-aconitase. Now from isocitrate to alpha ketoglutarate, what will be the name of the enzyme? Isocitrate dehydrogenase. Please, anywhere I write DH, dehydrogenase. Isocitrate dehydrogenase. Now, anytime you hear dehydrogenase, I've said something before about that. Oxidation reduction reaction is taking place, right? Oxidation reaction is taking place. Now, isocitrate to alpha ketoglutarate. Isocitrate dehydrogenase is the name of the enzyme catalyzing that reaction. And if there's a dehydrogenation reaction, it's either NAD plus is converted to NADH, or FAD plus is converted to FADH2. Is it not? Now in this case, NAD plus is converted to NADH. Now from alpha ketoglutarate to succinyl CoA, what is the name of the enzyme catalyzing that reaction? Alpha ketoglutarate dehydrogenase. And just like I said, dehydrogenase, what is produced here? NAD plus is converted to what? NADH. Good. Now from succinyl CoA to succinate, what would be the name of the enzyme? From succinyl CoA to succinate, what would be the name of the enzyme? Succinyl CoA synthetase. In some books you see synthase. At this point they don't bother you. Synthase. Now at this point, are we using NAD plus or are we using any of those? So what are we? What is produced here? Okay, GTP is produced, right? I will take this again. GDP is converted to GTP. What is GTP? Guanosine triphosphate, right? Now from succinate to fumarate, what is the name of the enzyme catalyzing this reaction? Succinate what? Dehydrogenase. Now succinate dehydrogenase here. What is converted to what? Dehydrogenase. What is converted to what? At this point, what is converted to what? FAD2 plus is converted to what? FADH2. We'll take this pathway again. Don't write. I'll give you time to write. Now, fumarate to malate. What's the name of the enzyme? Fumarase, right? Yeah, nothing is converted to nothing. Fumarase. Then from malate to oxaloacetate is what? The enzyme here is what? Malate dehydrogenase. And as we said, dehydrogenase, what is converted to what here? NAD is converted to what? NADH. NAD plus is converted to NADH. Good. This is your TCA cycle. But don't write here too. Alright, so let's take this. Now, pyruvate in the glycolytic pathway, pyruvate, the linked reaction, we say pyruvate is first converted to what? Acetyl CoA, right? And here we know that CO2 is given up, right? And what is coming in? CoH. And the name of the enzyme catalyzing this reaction is what? Pyruvate what? Pyruvate dehydrogenase complex. Okay, as we go on, we'll see that this pyruvate to acetyl CoA is not a one-step reaction. You not do it in this course. It's beyond the scope of this course. You do it in your final year. This pyruvate dehydrogenase complex is actually 3 enzymes in one, with I think 5 coenzymes. But for now, let's keep it simple as it is. Now, from pyruvate to acetyl CoA now, we said NAD plus is converted to what? NADH, right? Is it not? Now, acetyl CoA can then go into the TCA cycle. So here we said acetyl CoA will condense with what? Oxaloacetate. To form what? Citrate. And the name of the enzyme catalyzing this reaction is what? Citrate synthase. Citrate synthase. Now from citrate now, we said from citrate to what? The transient intermediate cis what? Aconitate. And the enzyme catalyzing that is what? Cis what? Aconitase. Now from cis aconitate to what? From what? Isocitrate. And the enzyme catalyzing this reaction is what? Still cis aconitates, right? Cis aconitase. Now from isocitrate now to what? Alpha ketoglutarate. Alpha ketoglutarate. And we say the name of the enzyme catalyzing this reaction is what? Isocitrate dehydrogenase, right? And dehydrogenase, what is converted to what here? NAD plus to what? NADH. Now from alpha ketoglutarate to what now? Succinyl CoA. And the name of the enzyme is what? Alpha ketoglutarate what? Dehydrogenase. And what is converted to what here? NAD plus is converted to what? So NADH. Now from succinyl CoA to what? To succinate. And the name of the enzyme we say is what? Succinyl CoA. Succinyl CoA what? Synthetase. Now, and what is converted to what here? What is converted to what here? GDP was converted to what? GTP. Now, you should note that GTP is equivalent to ATP. So 1 GTP is equal to 1 ATP. Now, succinate here is converted to what? Fumarate. And the name of the enzyme is what? Succinate what? Dehydrogenase. And what is converted to what here? FAD is converted to what? FADH2. Now fumarate is converted to what? Malate. And the enzyme is what? Malate what? The enzyme is what? Fumarase. Now from malate to what now? Back to oxaloacetate. And the name of the enzyme catalyzing is what? Malate dehydrogenase. Who's a malase? Malate dehydrogenase. And what is converted to what here? NAD plus is converted to what? NADH. This is the TCA cycle. First of all, write this down. Please don't mind the way my cycle is. My cycle is looking like. Write it down and I will say something about this.